Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
So, hello everyone. Can I please have a confirmation in the chat box that I am properly audible and visible? I welcome you all today for the day number 14 of CodeCamp. This is a series that we are presently having for as an initiative for habit building exercise for all of our students. And today we will be studying Introduction to Dynamic Programming. Okay. So before I begin, let me just wait a couple more minutes so that other audiences can join. And meanwhile, can you all please do a +1 in the chat box so that I could get to know your names? Okay. And I would request everyone to kindly keep the session interactive. Hello, Pratik. Hello, Dipanshu. Thank you for the confirmation. Hello, Ramchandra. Yeah, just do a +1 in the chat box. That would be more than enough. I could get to know your names. Hello, Raghuram. Okay, that's very great. Let me just share my screen and then. Okay, yeah. So before I start off, let me just give you a warm welcome, a very good evening to everyone who have joined with me this evening for this day 14th of Code Camp. And we are having this series from the last 14 days, and this will continue for another week. I hope you guys are attending these sessions regularly. Yeah, so you must have seen me previously. I took a session on yeah, during binary search session. I took a session on merge sort. I remember advanced sorting algorithm last week on Friday. Okay, so do you guys remember me? Or I was there last week Friday as well, and I am today here as well. Okay, so today we will be specifically studying Introduction to Dynamic Programming, and we are planning to solve 3 questions: one easy, one medium, and one of advanced level difficulty. Okay, and let's see if we are able to solve all the 3 questions, or if not, then we will keep the last problem as a take-home problem. Okay. So, how many of you are here in your third year or in your second year who will be having their internships or placements very recently? Just do a +1. Okay. I would really appreciate if everyone here is a little bit interactive with me during the session. That would most certainly help me deliver great quality content to you all. Hello Pratik, hello Dipanshu, hello Raghuram. I see 20 students are live with me, 25 students are currently live with me. Okay, so meanwhile I'm sharing my screen. Okay, so I hope my iPad screen is visible to everyone. Okay, so just let me know that it is properly visible, the font and everything. Okay, yeah. So this is my introduction. It's already written on my screen. My name is Gaurav Kumar Shaw, and I am presently in my fourth year. In fact, my fourth year haven't started yet. It will start in the month of August. Right now, I'm having my summer internship period, and I'm currently doing my summer internship at Cultfit. Okay, and I'm also a mentor at Geeks for Geeks, and I've been a mentor since the past 8 to 10 months. And yeah, so this is about me. So, how many of you are having your present internships and placement seasons? Can you please do a +1 in the chat box? That would most certainly be helpful for me. Okay, Raghuram, thank you very much. So none of you guys are having your internships or placements. It means, are you in your first year or anything? So even if you are in your first year or doing your PCA, whatever it is, just write about yourself in the chat box. Let the other audiences know about you as well. I really appreciate all of you joining this evening, Friday evening, with me learning dynamic programming. Okay, Raghuram, you are in your first year, I guess. Okay, then let us begin. Seeing you, we can say age is just a number. What do you mean by this, Poonam? Uh, do you think you mean to say that I look very young? Like I cannot be in my fourth year right now? Okay, working in non-IT. Oh, that's very great, Prashad, that you are willing to learn technical things even by being in non-IT background. Raghuram, you are in your final year. Okay, that's great. Okay then. Yeah. So can you all see the description of the this particular stream? You can basically see the links of the questions. Okay, the first question that we will be doing is Fibonacci numbers. How we can find the nth Fibonacci numbers using dynamic programming. Okay, problem one is nth Fibonacci number. Problem 2 is 01 knapsack. I hope this is a very popular problem and it has been very frequently asked in interviews. Okay, so 01 knapsack problem, and problem 3 is matrix chain multiplication. Okay, so this is a hard level problem. Okay. So we will be basically having a look into these three problems. Okay, so I hope everyone can see the links in the description. Let me just once again check that. Just let me know if you find the link, problem link, or I will give you in the description. Okay. Do you want me to give the links in the description, or you can just find it? Let me just put it here. Okay. I will share my screen as well and show you the questions. Oh, thank you, Poonam, for such a nice compliment. Yeah. This is the first problem that we will be doing, and yeah, let us begin with this particular problem, and then we will move to 01 knapsack. Okay. So before we begin, how many of you are actually aware of dynamic programming? So can you please tell me that why do we even need dynamic programming at first? Okay. So the question is, why dynamic programming? And can you just explain me what do you mean by dynamic programming? Okay, so why exactly do we need dynamic programming? What is the concept behind dynamic programming, and how does it is helpful in solving algorithmic questions? And in fact, how is it helpful in solving real life questions as well? And what type of optimizations does it provide? Okay, can anyone say me? Just write in the chat box. The number of audiences have usually decreased in the very first few days. So it means like the students who are present in the very day one aren't really consistent with studies going till day 18. Okay, but I can see few names. I remember Poonam, you were there in my last stream as well, the last week that I did on Friday itself. So are you presently attending all the sessions? You are in your which year of college? Okay, Raghuram is saying for optimization. That yeah, you are correct, Raghuram. So basically, the answer for this would be yeah. So the answer for this would be let's say that sometimes we need to solve a certain problems, and oh, you are a working professional. That is really great to know. Hmm. So certain problems can be solved with DP approach when there's a optimal substructure and overlapping subproblems. Yes, exactly, Pratik. So this is the correct answer. So let's say certain time number of times we need to solve a few problems, and in those particular problems we cannot apply any common sense or intuition or a greedy approach. So the best way to solve this problem is to try out all possible ways. Okay, whenever you see that a problem is asking you to trying out all possible ways. Okay, but sometimes trying out all possible way leads us to brute force approach. Okay, and brute force is an expensive in terms of time complexity. But you observe in the question that you can find optimal substructure or and overlapping subproblems. Okay, if you are able to find these two, in that case, what you can do basically is that you can optimize the brute force, the exponential time complexity into somewhat quadratic. Okay, you can optimize it using dynamic programming. Okay, so what exactly does this mean? So first, let me tell you about what exactly does overlapping subproblems means. So let's say you are trying to solve a problem, and then you try to see whether that particular problem can be broken down into smaller problem, which requires a similar type of computation. Okay, so what you want is that you want to compute that particular computation only once and not repeat the same computation over and over again. So what you are doing basically is that you are observing that whether there are overlapping subproblems or not. If there are overlapping subproblems, and in that case, what you will do, you will only compute this problem only once and utilize the result at different places. Okay, this is the meaning of overlapping subproblems. Okay, so can anyone tell me what is the meaning of optimal substructure? Can anyone tell me the meaning of optimal substructure? Sahil is asking, is DP very important for interview? Yes, it is extremely important for interview. In fact, if you are giving an interview, there is a high chance that if you are asked three problems, one will be at least from DP, one will be from graph, and one will be from any other random things. Okay, so DP is very important. Solution of smaller problems help building the solution for the original problems. Yes, exactly. So basically, Pratik is saying solution for the smaller problem is helping you build a solution for the original problem. This is correct. But there is one thing that you should add is that optimal solution for the smaller problem is that there is a certain structure, there is a certain concept which is available that will help you solve the smaller problem optimally. So once you are able to solve the smaller problem optimally, you can now use that optimal solution to solve the bigger problem. Okay, this is what it means: optimal substructure and overlapping subproblem. Overlapping subproblem means is that you will basically utilize that result for solving the similar kind of problems if without recomputation. Optimal substructure means the smaller problem you basically can find use the you basically know the concept of how to find a solution for the optimal solution for the smaller problem, and with the help of that you are basically finding the actual answer for the bigger problem. Okay, so this is about the two properties of dynamic programming. Okay, so let us now have a look into the first problem. The problem one, in problem one, we had a question. I hope everyone has seen the question. I have already shared the link in the comments. The question says that we are given a positive integer n, okay, and we have to find the nth Fibonacci number. Okay, so yeah, so in fact, let's say what are the Fibonacci numbers. I hope everyone knows about Fibonacci numbers. So the Fibonacci numbers are basically a particular series of numbers such that the first number is 0, the second number is 1, and the third number is again 1, the fourth number is 2, and the fifth number is 3, sixth number is 5. So basically, Fibonacci number is usually formed by the sum of the previous two numbers. Okay, so what I can say is sum of the previous two numbers. Okay, so in fact, according to the question that we have, so with that your definition dp is equal to recursion. No, dp is not equal to recursion. Recursion is one of the ways in which you can basically find all possible ways to solve a problem. But so if you are able to develop a proper recursive algorithm for your solution, now you can apply the concepts of dynamic programming and optimize that recursion. Okay, because sometimes what happen in recursion, you will see that same type of recursion is being called multiple times, and don't want that. So what you will do, you will store the value of that particular recursion somewhere and utilize that value to prevent the recomputation. Okay, DP is not just recursion. You can also solve DP problem with tabulation as well. Okay. The idea is to identify the optimal substructure and the overlapping subproblem. Okay. So this is the idea. So basically in the question, what does it say? We have to find the nth Fibonacci number. So what will be the second Fibonacci number? Can anyone tell me? So the first Fibonacci number will be 1 and the second Fibonacci number will also be 1. So this is the 0th Fibonacci number. We can call it the 0th Fibonacci number is 0. Okay. So the first Fibonacci number, second Fibonacci number, third Fibonacci number, fourth Fibonacci number, and this is the fifth Fibonacci number. Okay. So sixth one will be 8 and seventh one will be 13. Okay. So now, do you guys, okay. That is great. Yeah. So tell me, what will be the ninth Fibonacci number? Tell me, what will be the ninth Fibonacci number? Anyone? Sahil, Raghuram, Pratik, Poonam, Arushi. I would request all of you to kindly keep the session interactive. The session won't be very long. It will be mostly around like 70 to 80 minutes at max. Okay. And we will be doing 3 problems. So the ninth Fibonacci number will be basically the sum of 7th plus 8. Okay. And the 8th Fibonacci number will be basically the sum of 7th plus 6. Okay. Now the 7th Fibonacci number is 13. The 6th Fibonacci number is 8. So 26 plus 8. Okay. So 26 plus 8 will be 34. Okay. So the ninth Fibonacci number is 34. Yeah, that's great. Yeah, Pratik is correct, Raghuram is correct. Lavi, you are saying 21, that's incorrect. It will be 34. Okay. Yeah, there are a few properties of Fibonacci number that's totally unrelated to this topic, but I would recommend you all guys know this. So there is a property that GCD of Fibonacci number of A, comma, Fibonacci number of B is equal to Fibonacci number of GCD of A, comma B. Okay. So if someone is asking you, do you guys know this property? Tell me first. Did you guys know about this property, or did you got to learn this something new today? Okay, so I would recommend you all to know this. So what exactly does this meaning? So I'm going a bit off topic, but this is an important number theory concept, and oftentimes these are used while we are dealing solving problems related to Fibonacci numbers. So what happens is that, familiar with GCD. Okay, so basically let's say this is the 8th Fibonacci number. Okay, and this is the bth Fibonacci number. Now if someone is asking you to compute the GCD of 8th Fibonacci number and bth Fibonacci number, it means that Fibonacci number at the A place and Fibonacci number at the B place. So what will happen basically is that you can easily compute this by doing this. You can just say that GCD, compute GCD of A and B, the number of places, and then do a Fibonacci number. Okay. For example, if A is equal to 4 and B is equal to 6. Okay. So if A is equal to 4 and B is equal to 6, in that case, what you will do? You have to find the 4th Fibonacci number and the 6th Fibonacci number. Okay. So 4th Fibonacci number and 6th Fibonacci number and take the GCD. So what is the 4th Fibonacci number? The 4th Fibonacci number is 3 and the 6th Fibonacci number is 8. The 4th Fibonacci number is 3 and the 6th Fibonacci number is 8. Okay. So what is the GCD of 3, 8? So GCD of 3, 8 will be, can anyone tell me? Okay. And we can do the same thing by writing something like this. Fibonacci of GCD of 4, 6. Okay. So GCD of 4, 6 is basically, what will be the GCD of 4, 6? Can anyone tell me? GCD of 3, 8, since both are co-prime to each other, GCD will be equal to 1. And GCD of 4, 6 will be 2, because we see that 2 is a common factor which is greatest. Okay. So now this becomes equal to Fibonacci of 2, or the second Fibonacci number. Okay. So second Fibonacci number is also 1. You see, both the values are 1. So this is a property that you should remember. Okay. So I hope I delivered a few valuable things that you all did not know. Can anyone do a +1 in the chat box if you already knew about this concept? I hope you guys learned a new thing, right? Is that sure, Pratik, Arushi, Dinesh? Okay, so I will tell one more. Okay, didn't knew this. That's great. Okay, yeah. So basically, let's do one more thing. Yeah, so there is one more property that do you guys know that what is the sum of Fibonacci, the sum of squares of Fibonacci numbers? Hmm. So basically, the sum of squares of Fibonacci number would look something like this. So so Fibonacci of 1 square plus Fibonacci of 2 square means the second Fibonacci number square. Fibonacci of 2 square plus Fibonacci of 3 square plus Fibonacci of n square. So this, how can you find the value of this particular? Can anyone tell me? Result which is equal to this particular value. This is second result that I would recommend you all remember. Yeah. So basically, the value of this particular expression is something like this: Fibonacci of n into Fibonacci of n minus 1. Okay, or the nth Fibonacci number into the n minus 1th Fibonacci number. Okay, so when you product these two, basically you get this result. Okay, so this was a little bit off topic, and I would recommend you all keep this particular results in your mind. It may be or may not be useful somewhere, but I hope you guys remember this and it proves to be helpful somewhere in the future, and then you can thank me. Okay, so now let's move to the question that we had. We had to find the nth Fibonacci number. Okay, now first of all, how we will approach nth Fibonacci number. Can anyone write a small mathematical expression that basically helps us solve this question? Can anyone write us any mathematical expression that will actually help us understand the relation? Okay, I just told you verbally is that every Fibonacci number is equal to sum of its previous two numbers. So in fact, if I am able to define the first Fibonacci number is equal to 1, the second Fibonacci number is equal to 1, the third Fibonacci from third onwards, I can basically say it will be equal to first plus second, fourth will be equal to third plus second plus third. Okay, fifth will be equal to fourth plus third, like this. Okay, so this is how it proceeds. So basically what we can say is that for n greater than equal to 3, we can write f of n is equal to f of n minus 1 plus f of n minus 2. Okay. And if we just want to make it 0th Fibonacci number as 0, if we define f of 0 is equal to 0 and f of 1 is equal to 1, in that case we can say that f of n is equal to f of n minus 1 plus n minus 2 for every n greater than equal to 2. Both works. Okay. Generally, we start with 0 in computers. In computer science, we generally start with 0. So that is the reason we will define these two as base conditions, that the initial value that we need. Okay. And then try to find the relation. Okay. Yeah. So does this problem tell you that how we are going to solve this question? how we are going to apply dynamic programming or greedy approach or anything. Okay. Anyone? Okay, yeah. So, can anyone tell me, do you guys observe these two things in the problem? Overlapping subproblem and optimal substructure? Overlapping subproblem and optimal substructure. Okay. Yeah, Pratik is saying that naive approach, recursion without memoization. Okay, yeah. So before I move on to the next things, I will be recommending you that first I will be telling you what is memoization. Yeah. In fact, let us do the question and then we will understand. Okay. So yeah, let us have a look here. Hmm. Just remember a few things that I would recommend you all to remember. So memoization basically means that you are having a recursion. You have written a recursive code, a particular recursion code that is solving the problem by recursion, but the time complexity of this is exponential. Why exponential? Because this particular recursion is doing the same problem over and over again. So what you are doing basically, you are storing the values in a array. Okay, and whenever that particular recursion is being called again, instead of doing the recursion, you are taking values from this array. So this is reducing the time complexity in a very, very great fashion. Okay. So this particular approach is also called the top-down approach. Okay. Why top-down approach? Because in recursion, what happens? We are going something like this. Okay. And yeah, so this is basically going from top to down. Okay, we compute this particular value, then go this particular value and this particular value. And if we see that this particular thing and this particular thing, we need the same thing, in that case, what we will do? We will use these stored up values. So this is the top down approach. Now there is something called as tabulation as also. Now tabulation is basically bottom up approach. Okay, so so basically, we are solving in the direction of solving the base cases to the main problem. So we start with the base cases and then we gradually go up. Okay. So this is called bottom up approach, tabulation. We will try to do both of these using the and solve this and try to solve this Fibonacci number problem. I've already explained you the Fibonacci numbers. So can we solve this question of finding the nth Fibonacci number using recursion? Okay. Can we solve this question using recursion? Okay. Okay. Is my screen frozen? Okay, so Poonam is asking why are we solving DP while anyways we have to apply recursion. Yeah, basically, see, the thing is that we observe a problem and we see that this problem can be solved with recursion. Now, what makes you think that you can solve this problem with recursion? You see that overall you see the big picture the problem is, and you see that if I try to, there is a recurrence relation. So basically, there is a recurrence relation in whatever problem you are solving and in other base cases. So you can easily define a recurrence relation, do the recursion. But recursion is very expensive process. Okay. Now you are thinking that can I optimize this recursion? Now you observe that while you're solving this question, you can see that there are very, very sub problems which are getting recomputed once and once again. So what you're doing, so the computer, when you're writing a recursive code, the compiler sees and does the recursion every time. It doesn't care that that particular recursion has already been done previously, the same recursion, the same result, but they are doing it again and again. So that is the reason we are using the concept of memoization. And memoization plus recursion is nothing but applying the optimization of dynamic programming. Okay. Okay, Pratik, no worries. Okay. So let us first have a look into the recursive algorithm. So I just wrote a recurrence relation. F of n is equal to f of n minus 1 plus f of n minus 2. Okay. I just wrote this particular recurrence relation. Now what I want here is that, hmm, give me a minute. So how can I write a recursive function? Okay. So what I'm doing, I'm declaring a function f, okay, which is taking a parameter integer value n. Okay. And this function is returning me one thing. It is returning me f of n minus 1 plus f of n minus 2. Okay. So basically this particular line means that this particular function is recursively calling itself with the values n minus 1 and n minus 2. Okay. So what will happen? Let's say n is equal to 5. So in that case, 5 will call 4 and then 3. 4 will call 3 and 2. 3 will call 2 and 1. Okay, this 3 will again call 2 and 1. And this 2 will call 1 and 0. And this 2 will again call 1 and 0. This 2 will again call 1 and 0. Okay, so this is the recursion tree. Now you see that in the first step of recursion, what we are doing, we are calling 4 and 3. Okay, now this particular recursion tree, recursion is going on. It is computing the value of 3. But again, here I am repeating the same thing. So what I'm saying is that instead of calling this particular recursion again and this particular recursion again, I can just store up whatever results I get first. If I'm able to get the value of recursion of 3, I can just use up whenever it is being called once again. Okay, so this is the idea of recursion. Okay, now we have to define few base cases also, because once we are reaching up to 1 and 0, we don't want it go to negative, because Fibonacci of negative numbers are not defined. Okay, so what we will do, we have to write base cases also. So in this question, the base cases will be if n is equal to 0 or n is equal to 1. In that case, we will return 1. Okay, so this is the base case. I hope everyone understood it. This is a recursive code. Can anyone tell me the time complexity of this particular recursion code? Can you say difference between DP and recursion? DP is the optimization. Recursion is basically just idea. Okay, recursion is basically algorithmic idea. Okay, that you can apply a recursion. Recursion means calling the same thing once again, but by sending a different value. So that at what point recursion becomes DP? Recursion becomes DP when you are basically storing. Whenever you see that there are smaller sub problems. Okay, whenever there are sub problems, so overlapping sub problems, and you observe those patterns, and you can basically store the computation of recursion in any array, and then reuse those values whenever that particular recursion is being recalled. So in that case, you are optimizing the recursion and it becomes dynamic programming. Okay, got it. So can anyone tell me the time complexity of this problem? See, in this question, f of 3 is being called here, 3 is being called here, 2 is called here, 2 is called here. Here also 2 is called. Okay. So technically, I just want to call f of 5 once, f of 4 once, f of 3 once. Okay. And yeah. So once I'm calling f of 3, it will automatically, so 5 will call 4 and 3. So it will store the result of 4 and 3. Okay. So 5 calls 4, 5 calls 3. Now once 3 will call 2 and 3 will call 1. 2 will call 1 and this will call 0. Okay, so basically what is happening, yeah, so 2 will call 1, but the value of 1 is already stored, so this recursion is not called. Okay, and yeah, 4 will call 3 and 4 will call 2. So this particular recursion won't be called because I already have the value of 3. I will get it from here. Okay, now since I already have a value of 3, it means that I have a value of 1, I have a value of 2. So this recursion also won't be called. I will get the value here. Okay, and since this particular recursion was called just for one step, I got a value of 4, and then I'm technically calling these particular recursions. Okay, so this is what it means. Yeah, Pratik is saying that the time complexity is 2 to the power n. Hmm. Yes, the time complexity will be 2 to the power n. Okay, so now, so the idea basically is that we don't want to recompute, don't want to do the recursion over and over again. So that is the reason we want to store the values of recursion. Okay, so how can we store the values of recursion? So what we will do, we will declare a DP array. Okay, and initially we will initialize it with negative ones. So let's say I am declaring a DP of size n plus 1, and I'm storing all the values as minus 1 in this case. Okay, now what I'm doing is that I'm writing the same recursive code. Okay, I'm having a function int f. It is taking a value int n. Okay, now what exactly it is doing? Int n. Okay, now the base case is that if n is less than or equal to 1, it will return n. Okay, so if n is equal to 0 or n is equal to 1, this means that if n is equal to 0 or n is equal to 1, in both cases it will return 0 or 1. Okay, if n is equal to 0, it will return 0. If n is equal to 1, it will return 1. Now what I'm doing is that I am returning what I'm doing, I am storing the value in this dp table. So I'm writing dp of n is equal to f of n minus 1 plus f of n minus 2. What I'm saying that do this particular recursion and this particular recursion, whatever value you are getting, store it in dp of n. Okay. And then what I'm doing return dp of n. Okay. And whenever I am coming inside this particular recursion, I am putting one small check. I am checking that if dp of n is not equal to minus 1. If it is not equal to minus 1, it means that that particular value has already been stored and found using previous recursion. So I will not do the recursion once again. I will just return dp of n. So this is the recursive code. This is the dynamic programming optimization. This particular thing is called memoization. Okay. And the time complexity of this becomes big O of n. And can anyone tell me what is the space complexity? Hello Pratik, hello Dinesh, hello Poonam, hello Raghuram, hello Lavi. Can you all tell me what is the space complexity? Order of n for array, yes. So basically we are declaring array of size n plus 1. So basically the the space complexity will be order of n, because we are declaring a linear array. And apart from that, but we since we are utilizing the fact of recursion, so we are also having a recursion stack space of size n. Okay, so space complexity will be big O of n plus big O of n. So this is the recursion stack space. Okay. Yeah. So this is basically the recursion stack space. Now, can we optimize this further? Can anyone tell me? Can we further optimize this? Can anyone tell me? So overall, the space complexity is O of n only, because we don't write 2 of n. Yeah. So initially we are filling the D with recursion, and next time when we compute the value, we look up for D, and if available, then we return the value of DP. Yes, yes, exactly. Yeah. So let me do a dry run also. Okay. So yeah, that will be very helpful. Okay. Let's do something like this. So initially, let us declare dp of n plus 1. So n is equal to 5. So dp of 5 plus 1 will be dp of 6. Okay. So dp of 6 basically means we have 0, 1, 2, 3, 4, 5. So this is our dp array. Okay. So this is our dp array 0, 1, 2, 3, 4, 5. Initially, we are putting everything as minus 1. Okay. Let me just rub this. Okay. So this is our DP table. Initially, we are putting everything as minus 1. Now, what we are doing, basically, let's say, we are starting with f of 5. Okay. So we are starting with f of 5. Now, 5 will call two things. 5 will try to call f of 4 and f of 3. Okay. 5 will call f of 4 and f of 3. Okay. So now it will see that f of 4 and f of 3. dp of 4 is still equal to -1. dp of 3 is also equal to -1. So nothing will happen. It will recursively call. Okay. But now what happens basically is that since f of 4 is called first, it will this particular recursion will go down first. If you remember, we are writing f of n minus 1. So n minus 1 will happen first. So this particular thing will return and then recursively it will go. So this is how it proceeds. Okay. So f of 4 will come. F of 4 will call f of 3 and f of 2. Okay. F of 4 will call f of 3 and f of 2. Okay. This is done. Now what will happen? F of 3 will call f of 2 because left side proceed first, f of 2 and f of 1. Okay. Now f of 2 will call f of 1 and f of 0. Okay. Now f of 1 and 0 are basically base cases. Okay. So what will happen? This is base case and this is base case. So f of 0 is basically 1. F of 0 is basically 0 and f of 1 is basically 1. Okay. So this, what will happen? My table will get filled something like this. Okay, let me fill it with written. F of 0. Okay. So f of 0 becomes 0 and f of 1 becomes 1. Okay. Let me write with this. It will be much visible. Okay. So f of 0 becomes 0 and f of 1 becomes 1. Now dp table has started to being filled. Now these two values will return 0 plus 1 equal to 1 to f of 2. Okay. Now it will return f of 2, 1. Now what will happen? This is also a base case. Base case. So this will return 1. Now f of 1 is being returned 1. Okay. Now what will happen? This particular thing is a base case also and f of 1 is already filled. So but this since this is a base case, it will be returned as a base case. Now this particular thing returned 1. So 1 plus 1 will be returned 2. So now f of 3 will be put up as 2. Okay. And f of 2 will be put up as 1. Why? Because f of 2 was given 1. So it will be put f of dp of 2 will be equal to 1. dp of 3 will be 2 plus 1 equal to 1 plus 1 equal to 2. dp of 3 is equal to 2. Now dp of 3 and it will try to compute this. But it will see that this particular recursion will not happen because if dp of 2 is already stored. dp of 2 is equal to 1. So it will give dp of 4 is equal to 3. Now this particular value is 3. So what will happen? This will give return 3. And now what it will try to compute dp of 3. Okay, recursion of 3. But recursion of 3 means dp of 3. And dp of 3 is already calculated, which is equal to 2. So 3 plus 2 will be equal to 5. Okay, and finally dp of 5 will be equal to 5. So basically this particular recursion was also not called. So we are saving two recursive paths. Okay, this was called, this was called, this was called, this was called, this was called. Okay, this was base case, this was base case. This was prevented. This call was also prevented. Okay, so did you all try understood the dry run? Poonam, did you understood the dry run? How did we solve this question? And I hope your doubt has been cleared. Okay, that's great. So I see around 13 people are right now live. Yeah. So audiences are decreasing day by day. I would recommend everyone to kindly attend the sessions live. That would be really great. Okay, it's just a matter of an hour. Okay. So this is basically the recursion part. Now we also have something called tabulation. Okay. So so let us have a look into tabulation thing. Now, can we optimize this further? I asked you this question. The answer will be yes, we can optimize this. But how can we optimize this? We can basically do a space optimization. Space optimization means that the space that we are basically taking this for recursion stack space. The recursion stack space that we have can be optimized. The recursion stack space that we have can be optimized. How so? By using the concept of tabulation. Okay. So tabulation basically means that what we will do, we'll go a bottom-up approach. So basically, we will start with the base cases. Bottom-up approach means we start with the base case and then we proceed to the value of n. Okay. So what we will do? So first of all, we will declare a DP table. Okay. So this DP array will be same thing. DP of n minus 1 will initialize fill it with minus 1. After that, what we will do? We will write the base cases. DP of 0 will be equal to 0 and DP of 1 will be equal to 1. Okay, this is just writing the base case. Now what will I do? I will run a for loop. Okay, for loop from int I is equal to 2. Just a minute. Okay, so I will run a for loop. For loop will start from I is equal to 2, I is less than equal to n, and I plus plus. What I will do, I will just write dp of I is equal to dp of I minus 1 plus dp of I minus 2. So initially, when we were doing memoization, these particular things were computed using recursion. But right now, I am just putting up these values in array. I'm storing the value of 0 and 1 in the array, and using that particular value, I calculate dp of 1. Then 1 and 0, I'm calculating 2. So we are moving bottom up. From 0, 1, we move to 2, then to 3, then 4, and then so on. Okay. So these are just 0 O of 1 operation. Okay, because I am just looking up the values from the array. And since we are running a for loop, this is an O of n operation. So the time complexity becomes O of n, and the space complexity is also O of n because of the DP array. And no stack space is needed because we are not doing recursion. Okay. So this is the tabulation code. I hope everyone understood it. Can I please have a +1 in the chat box if you have understood this code? Then we can proceed further. The link of the question is already there. You can start writing code and try to submit it. Okay. So yeah, so let us take a 2-minute break and then I will go and drink water. And meanwhile, you can try to submit this particular code on the GFG platform. Okay, and see you in 2 minutes. Okay, I would request all of you to kindly stay here and not just leave. Okay, because yeah, that will be helpful. Okay. Yeah, so I see everyone is presently here. No one left. That's great. Thanks a lot for staying. Can I please have a plus one in the chat box? So just to confirm that you guys are here and you are with me, and we will start with the next question. Yeah. Is tabulation always better than memorization? Yes, it is always better because in tabulation you are not basically utilizing the recursion stack space, but recursion is actually easier because writing recursive states is actually very easy compared to thinking the way of how you can formulate the concept using tabulation. Okay, so what happens is that students really start learning from recursion and then try to optimize the recursion and then think of writing tabulation code. Okay, so in fact, what will happen sometimes in interview, you will start writing with recursion code, but the interviewer knows that student usually face difficulty in writing tabulation code. So they will say that do in tabulation only. Okay, because explaining tabulation is also a little bit tricky. Because recursion, you can just explain that this is a recursive state, and you can just explain that this is the recursive state, and then once you basically recognize the optimal substructure and the sub problems, so now you can just memorize the solutions. Okay, and then the problem is solved. But thinking in terms of tabulation is a little bit difficult because you're going bottom up. You're going from the smaller problem and then trying to solve the bigger problem. So this is how it becomes a bit difficult explaining it verbally. So it is recommended that we first write the recursion, then memorize that, and then try to write the tabulation. Okay. Tabulation is also part of DP. Yes, yes, it is a part of DP. It is an idea of, of solving, optimizing the recursive states. Okay, and then yeah, that's great. Okay then. So right now, are you guys doing any kind of summer internship? Because if you are in your college right now, then you would be doing some kind of internships in this particular summers. Is that so? Also, it can be further optimized with constant space. Yes, we can do that. We can also do that with constant space. But remember one thing, that not all problems can be optimized with constant space. We can only optimize those with constant space if the basically what is happening if the current DP state, if the current DP state is only dependent on the previous few DP states. Okay. So what will happen is that, let's say in this case, DP of I is only dependent on the last two DP state. So DP of I is dependent on DP of I minus 1 and DP of I minus 2. Okay. So what we are doing, we are storing all the DP. Okay. So that if we are storing DP of 1, DP of 2, DP of 1000, we are storing all the value up till DP of n. But when we are computing DP of 1000, we only need the last two values. Okay. So in that case, what we will do, we will only store the last two values always. Okay. So we can just write a very simple space optimized condition here. Let's have a look here. So what we will do, let us declare a value called prev. Okay, so int prev is equal to 0, and let's say int previous, let's say int prev is equal to 1 and previous 2 is equal to 0. Okay, so now what we will do, we will run a for loop int I is equal to 2 to n. Okay, and then what we will do, we will declare a value called current. Now current will be equal to the sum of the previous two values, that is equal to previous plus previous 2. Now what we will do, we will update our previous 2 is equal to previous, and previous is equal to current time. If we are able to do these, in that case what we will say is that we are not basically utilizing any spaces, we just declare two variables and we were able to solve it. Okay, so that time complexity still remains big O of n, but the space complexity becomes the constant time. Got it? So Pratik, am I clear? I hope this particular. So basically, we saw three different ways of writing the same problem. Okay. So this is how exactly dynamic programming works. You can basically write in three different ways for the same problem. Okay. So yeah. So yeah, I was asking that where exactly are you guys doing your internships if you are doing any? Okay, and even if you're not doing, it means that you will basically get to do that. Yeah. Poonam said here that you're working as a professional. Like I'm very curious that yeah. So like in which company are you working? And like what exactly is the motivation behind attending the sessions or by Geeks for Geeks? Yeah, so I would recommend you all to kindly like I'm asking this question just to make the session interactive because me just blabbering DSS stuffs for a constant 1.5 hour will get you bored definitely. So I'm trying to keep it on a lighter note. Yeah, like right now I'm doing my summer internship at Cultfit. I'm not sure if you have heard about this company, but it's a very popular company here in Bangalore. So yeah, right now I'm sitting in my office itself and doing the stream. Okay, and I'm doing my summer internship here. So yeah, if you have anything to tell me, ask me. You can write in this in the comment section, or we move to the next question, which is 01 knapsack. I am putting the link in the comments. Yeah, we will solve this particular question. We will see the recursive states. We will see the tabulation state. We will see the space optimization state, and we will also complete try to do few, I will basically give you the last question as a take home question as a homework. Okay, Poonam, that is really really great. Upskilling yourself. Citibank. Okay, okay. So you're working as a software engineer there. Okay. Can you refer me in your company? Like I'm not sure how exactly that will work because I am not here full time. I'm just a student right now doing my internship. Like once I get a full time opportunity here, I can definitely refer you. Okay. You can ping me on LinkedIn. Like you can get connected with me on LinkedIn right now itself. That would help me. Okay. So let me just share my LinkedIn profile as well. In that case, if you would like to get connected with me over LinkedIn, that would most certainly be helpful. Okay, just a minute. Let me. Okay, so Dinesh, remind me once I start working full time next year, I will definitely refer you. Okay, yeah. So let's start with 01 knapsack. Okay, so 01 knapsack, how exactly does this thing work? I have already sent the problem statement in the link. Okay, so let me just read the problem statement and I'm letting you know how to solve this question. Yeah. So the problem statement is something like this. Let's say there is a thief, okay, and the thief is planning to rob a particular house, okay. Now that particular thief has a bag with itself, and the bag has a maximum weight of W. Okay, so you got a bag. The bag can only accommodate weights up to W. Okay. Now there are n items in the house. Every item has a weight represented by the WT array, and every item has a value represented by the value array. Okay. So there are n items, and every item has a weight, and every item has a value. Now, thief has only one bag, and he can only put those items in the bag which can be actually accommodated. So the maximum limit is weight W. So the sum of all the items that a thief takes cannot exceed the value W, capital W. Okay, and so you have to answer that what is the optimal way for the thief to actually steal the items such that the value is maximized. Value is maximized. Okay. Now, why is this problem important? Because people will think in terms of greedy and will try to apply intuition and common sense in solving this, and usually will that get to a wrong answer. Okay, so let me show it to you how. So let's say if capital N is equal to 4 and value is equal to okay, so let's say capital N is equal to 4 and capital W is equal to, let's say 5. Okay, and this particular array is, let's say 1, 2, 4 and 5, and 5, 4, 8 and 6. Okay, so you have these particular arrays. Okay, this is weight and this is value, and now finally what you are doing is that you have to basically answer that what is the best way to take the values, right? Now what will happen here is that let's say the thief can take a value so since he can only accommodate up to 5, so what he will try, let's say if he takes 8 and 5 together, value of 8 and value of 5. So in that case, 4 plus 1 will be equal to 4 plus 1 will be equal to 5. Okay. So 8 plus 5 will be equal to 13. He's taking the value 13. Okay. Now you have to basically tell me that why doesn't the greedy solution will work? Hmm. Can anyone tell me? Yeah. So greedy idea is basically is that we sort the entire array with value because we want to maximize the value, right? And since we want to maximize the value, it means that we take the that particular item, which is the maximum value together, and then we can just take it in that order. But that will not get you the correct answer. Can anyone tell me why? I can prove it to you with the help of an example as well. So let's say that we got the weight array is equal to 3 comma 2 comma 5 and the value array is equal to 30 comma 40 comma 60. Okay, capital N is equal to 3 and W is equal to 6. Okay, now what does this mean is that Hmm. So by greedy, if you would have gone, the answer would be we would have taken only 60 because 5 is basically 60. The maximum weight that we can take is 6. So in that case, what will happen? We would have gotten a 60. But let's say we would not have selected this particular bag, we would have selected these two bags. So 40 plus 30 would be equal to 70, and the weight, total weight 3 plus 2 is equal to 5, which is less than 6. Okay, so it means that if we would have selected 40 plus 30, we would have got a better answer than selecting greedily. Okay, so if greedy is not working, then it brings us to what concept? I would recommend you all to kindly keep the session interactive because it will certainly motivate me to write. Okay, so select max, try all possible combination, and then select the best value. Yes. So if the greedy strategy is not working, it means that the best way we can actually solve this question is try to select all possible, try to actually go through all possible combination, and then choose the one which is yielding us the best value. Okay, so this is how it should work. Yeah, let us see then. Okay. So okay then, yeah. Let us have a look into the strategy of how we will solve this. So the question is that we will try out all possible combination, try out all possible combination, all possible combination and choose the best one. So what does trying out all possible combination in here? Here it means that we will basically for every item we will decide that whether we want to pick that item or not pick that item. Okay, so if we are picking that item, then we will try to go to the next item. If we are not picking up that item, then we will also go to the next item and see what the best thing would work out. We'll do all the possible things, but the constraint is that what the sum of all the items that we're picking, the weight of the sum of all the items should be also always less than or equal to W. Okay, so since for every item we have two possibilities, for every item, since we have two possibilities, we can write a recurrence relation to solve this question. Okay, so now how will exactly this recurrence relation works? Let us have a look here. So what we are doing is that let us write a function. Okay, This particular function will take two values. The first is the index. Okay, why index? Because we are starting from the, let's say, whatever value we are starting. Okay, so index is particularly the item that we are considering right now. Okay, and int w is the maximum weight that our back can accommodate right now. Okay, now what we are doing is that there are two possibilities. Okay, the first possibility is not taking. Okay, why not take? Because I don't want to take the item present in the present at the index, the position ind. In that case, what will I do? I will add 0 to my answer because I am not taking. Then I will recursively call the same function for the value int -1 because I want to move to the next step. Okay, because I want to move to the next item because I am not taking that particular item. Now, since I am not taking that particular item, the back capacity will remain as it is, W. Okay, it will not decrease. If I am taking that item, then the back capacity should decrease because I put up something inside my bag. Okay, now what will I do? I will write take. Take is a variable. I will write that with int min. Why int min? Because I am taking the maximum, right? And then finally, I will just do wt of int. I will check this particular condition less than equal to w. Why I am checking this condition? Because now I want to take this particular element. So basically, what will happen is that I will check that whether the weight at that particular index is lesser than the actual value of my bag or not. If it is so, in that case, what will I do? I will update my take variable. Take value will become value of index plus I will recursively call for the next part. Okay, now this part will be index -1 because I want to go to the next item. Then I will also update the weight. Weight updation will be w minus w2 of index. Okay, you see that if we haven't done this particular check, in that case, what would have happened? This particular thing would have become negative. And once this would have become negative, then that would give a error because we basically don't have idea of negative weights. Okay, now the base cases. Now what will be the base cases? The base cases is that we are accepting two things. First, the weight can become 0 or the index can become 0. Okay, now let us think about the base cases. What will be the base cases? The first condition is if index is becoming 0, if index is equal to 0, we have reached the first position, the very first item. Now we also have two things that we can do. Either we can take the item or we cannot take the item. Now if we are taking the item, it means that the weight present at the 0th index should be less than or equal to the W. If it is so, in that case what we will do, we will just return value at 0. Okay. Why value at 0? It means that we have taken that particular value. Okay, we have taken that particular. Okay, so we have basically taken that particular value at 0, and then we are putting that, right. And if the value is basically the weight, the value exceeds the maximum value that we can put in the bag, in that case, we will return 0. Okay, so this is the base cases. I hope everyone understood it. Okay, yeah, Pratik, you are correct. Do we sort by weight? We will not do any kind of sorting because sorting is a greedy idea. We won't be doing anything like that. We will try out all possible cases and then we will select. Okay. For every item, we will either pick that item or not pick that item and calculate the total value that we can get at the end. By doing so, keeping in mind that the maximum we can do is W. Okay. So how we will actually use DP here? Okay, how can we? What is the time complexity? Can anyone tell me the time complexity? It will be of this brute force recursion? Do we need to? No, we don't need actually. So n items can be picked or not. So 2 to the power n. Yes, exactly. It will be exponential time complexity. Okay. So let us have a look here then. Now let us try to do a DP optimization of this question. So I will write the same function. Okay. And I will try to fit my code in one page itself so that everyone can see all everything written here. Okay. So first of all, we will write intf. Okay. Now this will accept few things. The first will be the index. Okay. Now the second thing will be integer w. Okay. And we already have a DP state initialized, so I'm not writing that. Okay, now the base cases. The base cases will be if index is less than or equal to 0. Okay, or in fact, let me just write index is equal to 0 because that makes more sense. Okay, so the first thing that we will check that whether weight at 0 is less than or equal to W or not. W is the present capacity of the bag. In that case, if it is equal, we will return WT of 0, or in fact, we should return the value of 0 because I am updating the value. Okay, so it will return, if I'm picking this particular element, it should return value of 0. Okay, after that, what will I do? I will write else. If it is not possible, then in that case I will return 0. Okay, so this is the base cases. So let me just write, this is the base cases. Now finally, after that, what will I do? I will write the recursive state. The first option that I have, I am not taking that particular option. Okay, so int not taken will be 0 plus, I will recursively call this function for int minus 1 and the value w. Okay, after that, what will I do? I will declare a value called taken, and I will initialize it with int min. Int min is a very smaller value, very small value. And if the value of wt of the present index that we are in is less than or equal to w, it means that we can actually take this element. So we will write taken is equal to the value present at the index, value of index, plus the function. I will recursively call the function for the value int minus 1 and w minus wt of int. Okay, and then we will just return. What we will return? We will return dp of int w is equal to max of taken comma not taken. Okay, so we are taking this value, storing it in our dp table. Okay, and then we are returning that. This line will do that. And in here, what we will do, we will write our optimization, that if dp of index comma w is not equal to minus 1, in that case we will return dp of index and w. Okay, we are initializing our dp table with dp of n. Okay, so our dp table is being initialized with something like this, dp of n comma w plus 1. Okay, why do we need like this? And we are initially putting everything as minus 1. Okay, so we are starting with dp of, actually we are sending n minus 1. So initially when we will call this function, we will send the value n minus 1 as index. Okay, why? Because this is our, let's say, our array 0 1 2, the last value is n minus 1. So we are initially sending it as n minus 1, and we are sending the value w as it is. Okay, w, so w is, let's say, 5 kilo, so 5 kilo will be like this. So we are initializing it with 6 because we want 0 1 2 3 4 5 6, 0 1 2 3 4 5. Okay, so this is basically the 5, the value like that. Okay, this is 5, which is equal to the value w minus 1, w minus 2, w minus 3, and then finally 1 is basically 1 2 3 4 5. Okay, and if it comes to 0, it means that the weight is over. Okay, got it? So index, the value index is being iterated on index minus 1, that is equal to n minus 1. Okay, n minus 1 to 0, both inclusive. Okay, this is the index that we are iterating. Weight has been iterated on the value weight to 1. Okay, I hope everyone understood it. And if the weight becomes even less, it will accordingly take care. Okay, because the value of weight, WT of 0 should always be less than equal to W. Okay, that condition has to be checked, otherwise it will return automatically 0. Okay, so can anyone tell me the time complexity of this recursive memoization? This process is called memoization. Hi Pratik. Hello Dinesh. Hello Pratik. Hello Raghuram. Hello Poonam. I hope you guys are present here. The session won't be very long, just a few more minutes, and then just like 10-15 minutes, we will do a bit of discussion. We'll write a tabulation code, and then the space optimization part, you can do it by yourself. Okay. Yes, exactly. The time complexity will be n into w because n is the number of items, w is items. So the time complexity becomes n into w. Okay. And what will be the space complexity? Can anyone tell me? What will be the space complexity? Aditya, hello Aditya. Time complexity and space complexity for this memoization. Pratik said n into w, that is correct. And this space complexity, can anyone tell me? Storing DP is n into w, but recursive stack not sure. Okay, yeah. So yeah. So basically, what is happening is that space complexity will also be equal to n into w, but since we are using recursion, in that case, what will happen? We have to actually have an extra stack space of n. Okay, the stack space will be linear in nature, so it won't be n into w. Why not? Because we only have n items, and it keeps on that, right? O of n for stack, not w. Okay, because there are n items, and we are basically what is happening here recursively. We are iterating on index. Okay, so we are keeping w fixed. Okay, so we are basically updating the w as well, but we are trying to iterate over the index. And what will happen? There will be a case in which all the items are picked. Okay, so that will be the worst case basically for recursion stack space, and it will contain all the elements in the stack, right? So recursion stack space is n, O of n. Okay, so this is the space complexity. Okay. So now we will look into tabulation, but before that, yeah, let's. If you guys have any question, you can ask me. So you guys tell me from which cities do you live in? Like I am from Kolkata. My hometown is from Kolkata, and I did my schooling there. And like I'm doing my college from IIT Kharagpur, so it's like 2 hour distance from my hometown. And right now I'm in Bangalore because of my summer internship. Okay, so do you guys stay in your hometown or do you stay away from your families? How exactly is your life going on? Yeah, like I know I'm very bad at making these small conversations to make people feel lighter, but I suppose I can make this. Yeah. Okay, Pratik is asking a technical question. Pratik is asking in an interview setting, do we need to come up with tabulation approach too if the interviewer asks? Okay, I suppose everyone wants to study and not do any other kind of uh, lighter talks. Then that is great actually. Okay, yeah. So basically, what happens is that that interviewer will not tell you to actually say some kind of approach that you want to solve. Okay, he will just put you a question. Now, what you have to do is that you start with the most naive approach. So let's say if he gives you 0 1 knapsack, don't write the memoization code. First try to say that greedy approach will not work and you have to use some kind of recursive approach because you want to try out all possible combination. But recursion is an expensive approach, so in that case you can use an idea of memoization. You will cache all the solution. Memoization is basically caching. So you will cache all those solution in a tabulation array. Okay. Fun fact, like right now in my internship, I'm doing a work on caching, memory caching. So basically what we are doing is that caching makes things faster, right? So we are actually applying the idea of caching. So what happens is that I'll just share a small piece of info. So basically, is that, let's say we have an application. Let's say a web application is there. The backend of this web application is trying to fetch data from the database. Okay. So for every query it makes, it will try to call the database and it will go to the backend. But what happens is that every time a call is being made, it will try to go to the DB and then ask. Okay. So instead, what we do basically is that we cache all the results in a like we don't have to basically go to the DB every time. We store everything in a cached memory, which is basically local memory. Okay. So the first time that it is called, the cached memory will actually get in your computer. Okay. Now every time this web application, the backend will not call the database, but it will call the cache memory in your local machine. So what is happening is that this is basically utilizing the concept of memoization. Why memoization? Because what is happening is that you are writing a particular like this particular cache is in your local memory, and yeah, everything you just cached because it is basically storing taking your memory to load faster, because database is stored somewhere. Okay, like somewhere physically in a data center of Amazon Web Services. So every time you don't want to make a call to DB, that will be very expensive operation for you also, and for the people who are maintaining the website, for the people who are maintaining the servers. So it says that the first time you try to load a particular website, it will store everything automatically in a cache. The thing is that every time you are trying to update something, so let's say you update something, now what will happen? It will update in the database also, and it will simultaneously update in the cache also, because the updating is a sending a request to the database, but it means that the cache should also get updated, because you want updated value and not the older values. So this is also an engineering problem, that while we are caching. So if you're a software engineer, like right now I'm presently learning and applying these stuffs in my internships. So somehow the knowledge of DSA that we learn actually gets applied in the working domain as well. Okay. So this is a small piece of information that I wanted to share. Yeah. So I guess Poonam must be knowing it, because you're working as you're a working professional, so you must be knowing about these things. Like I'm new to this industry, but she must be knowing it. Okay. Yeah. So let's move to the tabulation code of this particular. Okay, so now how can we do a tabulation thing, right? So tabulation, as I said, it's a bottom-up approach, and when we are doing a bottom-up approach, we have to start with the base cases, right? Hmm. Yeah, so I guess the number of audiences are decreasing, but I will keep the session for 10 more minutes, and then we can log off. Okay. So how exactly we will do this? So first of all, we have to declare a DP table. Okay. A DP table will be of size n and w plus 1, as we just did there. And we'll initialize everything with it with 0. Okay. The base condition. The base condition is that when we are reaching to the last element, if that particular value is less than or equal to w, it means that we can pick that element. So what we will do basically is that, let's say this is our DP table. Okay. So let me just do a DP. Let me just write a DP table. Okay. So for n is equal to 5. Okay. So this is n and this is w. So 0, 1, 2, w is equal to, let's say 6, 2, 3. So w is equal to 5 and n is also equal to 5. Okay. So this was the condition. 1 minute. N is, what was the value of n? The value of n in the previous example was 4, I guess. Yeah. So let me keep the value of n as 4 and w as 5. Okay. So the value of n is equal to 4 and w is equal to 5. So in this case, it will be equal to 0, 1, 2, 3, 4, 5, and n will be equal to 0, 1, 2, 3. Okay. So this will be our DP table. Let me just draw this particular table. I will fill this particular table for you all. Just stay with me for 10 to 15 minutes. Meanwhile, you can, if you want to ask something to me, you can write that in the chat box. That would be certainly helpful. Okay, so now what we're doing, we are filling everything with zeros, right? We are filling everything with zeros. So yeah, first let's assume that everything is filled with 0. And the base condition says that when we are at the last item, that when we are at the very beginning, that when index is equal to 0, so index is basically iterating on this particular approach. Okay, this is index. Then if the value of weight at 0, if the value at weight at this particular 0 is less than equal to w, in that case what we will say, we will take that particular element, right? So this is how exactly the indices, the base case is working. So I'm just writing one particular loop here. Just have a look here. For int I is equal to wt of 0, and I is less than equal to w, and I plus plus. Okay, and then we are doing dp of 0 comma I is equal to value of 0. So what exactly is this thing doing? Let us see that. So before I proceed with what exactly is this thing doing, let me just so the weight array. So our weight array is 1, 2, 4, 5, and our value array is 5, 4, 8, 6. Okay. So this is our weight array, and this is our value array. I know the screen has become a bit of clumsy, but please stay with me. Let me just have a look here. Okay, so this is the weight array and this is the value array. Now what we are basically doing is that int I equal to weight of 0. So what exactly weight of 0 means? Weight of 0 means the value 1, because the first item has a weight of 1. So we are iterating from I equal to 1 to I equal to w. That is basically the item of the weight of the very first item, that is 1 kilo, till the very end. Okay, now what we are doing, this particular thing is indicating row and this particular thing is indicating column. So row is always 0, okay, because we are standing on the right in the base case. So this particular column, so let me just highlight with this color. This particular row is actually the base case row, okay. Weight is equal to 0. And what we are doing, we are basically writing, okay, so what we are doing basically is that we are filling the value is equal to 0 to this particular thing, right? So what we are doing now in this case is that dp of 0 comma I, it means that the base case, that is the first the value index number 0, and the value I is starting from weight equal to 0. So weight equal to 0 is equal to 1. So it means that the value 1, I am putting the value 0, which is equal to 5. Okay, it means that you are taking that particular value and putting in your bag. Now what you are doing basically is that you are putting 5 everywhere. Okay, it means that dp of 0 comma 1 is also 5, and dp of 0 comma 5 is also 5. Okay, so it what exactly does dp of I comma j means in this case? So dp of I comma j means that what is the maximum value that you can actually take, given you are considering all the elements from 0 to I. Okay, so maximum value that you can take if you are considering all the elements from 0 to I. Okay, 0 to I, given that your size of back size capacity is j. So if you are considering only the 0th element, and if you are considering only the 0th element, and your back size is 1, you can take a value 5. If your back size is 2, you will only take a value 5. If your back size is 3, then also you can take a value 5. Okay, and if your back size is 4, then also you can take a value 5, right? Okay, so now what we are doing basically is that hmm, now we will write our tabulation code. Okay, now we want to fill up this DP table. So we will write something like this. For index will start from index, yeah. So we are starting our index. It will start from index equal to 1 to index will be less than n, and index plus plus. Okay, now what we are doing, we are going to do a cap. Cap is basically for the weight. Weight equal to 0, cap is less than equal to w, and cap plus plus. Now what we will do, we will have two variable, int not taken. Int not taken will be equal to 0 plus dp of int minus 1 and cap. Okay, this is int minus 1 and cap. And then we will have something like taken. Int taken will be equal to 0 plus dp of, it will not be 0 because, just a minute, int taken should be initialized with int min. And then we will check that if the weight of the present index that we are in less than equal to cap, in that case what we will do, taken is equal to value of value of index plus dp of index minus 1 and cap minus weight of index. Okay, so this is the particular weight that we want to and then we will store this particular index comma cap is equal to the max of the both the values. Okay, and then finally what will be our answer? Can anyone tell me what value will give a, after we fill the dp table, what will be our answer? Pratik, can you tell me after we fill the dp table what will be our answer? But value of dp of n minus 12 will have the answer. Yes, exactly. The value of dp of n minus 12 will have the answer. Yeah, exactly. So the value of dp of n minus 1 and w will have the answer. Okay, so if you just follow the code and write it table, you will get to understand this why exactly this is happening. Okay, so the third question, I'm sharing the link. The third question is basically matrix chain multiplication. I'm sharing the link in the chat box, and before we wrap up our session, just let me know that what exactly is the time complexity and the space complexity for this tabulation approach. Okay, I will discuss the question of matrix and multiplication, and then we can basically complete this session. Okay, okay, just a minute. Yeah, so basically, yeah, this is the particular code. So what is happening? We are writing from int. We are traveling from int index is equal to 1 to index is equal to n, and after that, what we are doing? This particular line is iterating across the weight cap equal to 0 to cap equal to w. We have two cases: the taken case and the not taken case. The not taken case, if you're not taking this particular case, we are just proceeding to the next item. Let's dp of n minus 1, n minus 1 and cap. Okay, so let's say if you're not taking, it means that whatever value you stored it at in minus 1, you will store that particular value, cap will not decrease. But if you're taking that, it means that weight of index is less than equal to cap. So it means that we are taking that particular item index, so the weight at that particular value, and if it is less than equal to cap, it means that we can take this, so value will be equal to int. Okay, so why value will be equal to int? Because value array and the index array are going parallelly, but the last value that we stored was int of int minus 1. Okay, and the value that we can actually get by writing cap minus weight of index. Okay, because we're taking that particular value, right? So whatever value we have actually accumulated till index minus 1 and cap minus weight of index, we'll store that. Take that maximum and store it there. Okay, so dp of I comma j is basically is that you consider all the elements from 0 to I, and let's say you have a capacity of j, so that is the what is the maximum value that you can put in your bag. Okay, so this is what exactly the code is trying to say us, and this is exactly, yeah. The time complexity of this particular code will be same as the, so it will be same as the recursion also, because we are using n into w, but we won't be using the stack space. Okay, and the space complexity will be big of n into w, and the space complexity will also be big of n into w plus no stack space. Okay, got it. Now there is a space optimization also, but we don't think we have so much time for that. I would recommend you all to read it by yourself. You can find GFG articles for the same. Now let's move on to something called as MCMDP, matrix multiplication. I have already sent the question in the link, so I will just explain the question to you. The question says that let's say you've got a array of size n, okay, and yeah, the array contains n elements, which is representing the dimensions of n minus 1 matrices. This type of DP are called partition DP. Okay, partition DP. And the question is that every let's say the 10, 20, 30. If the value of n is equal to 3, and this is our array, so this particular array is representing two matrices. N minus 1 is equal to 2. Two matrices of dimension. Let's say the first matrix is A, and the second matrix is B. The dimension of A will be 10 into 20, and the dimension of B will be 20 into 30. So, array of I is representing a matrix of dimension ARR of I minus 1 into ARR of I. Okay, this is being represented. Now, can anyone tell me, if I am multiplying the matrix A and B, how many operations will it take? Okay, so I hope everyone knows that the conditions for matrix multiplication you must have learned in your class 11th and 12th is that if the number of columns of matrix A is equal to the number of rows of matrix B, which means that this particular value and this particular value should be same. Okay, so number of columns of A should be equal to number of rows of B. Then you can multiply A into B. Okay, all the order should be clear. Remember, in matrix multiplication, A into B is not equal to B into A. Okay, you have to remember this. Okay, so dimension should be like this. The number of columns of A should be equal to the number of rows of B. In that case, you can do like this. Matrix is represented as something like row into columns. Okay, understood. Okay, Pratik. Hello, Poonam. That's great. Okay, then. Yeah. So, can anyone tell me that how many operations we will need to multiply A into B? And I will just give a small intro that why exactly do we need MCMDP and what it will help us find. Number of operations to multiply A into B. So what happens here is that if the dimension of A is equal to 10 into 20 and dimension of B is equal to 20 into 30, the number of operations needed to multiply A and B will be 10 into 20 into 30. Okay, which is basically 6,000 operations. So you'll need these many operations to multiply A and B. And the question is saying us that we are given an array of size n, which is basically representing n minus 1 matrices. So let's say I have got three matrices A, B, C. So there are two ways I can multiply A, B, C. I can either multiply A into B and then multiply C, or I can multiply A into, first I multiply B into C and then multiply A. So both will yield different number of operations. Different number of operations. Okay, you can try this out and see. So the question says that which is the ideal way of partitioning this matrix such that you can basically get least number of operations. Least number of operations to multiply two matrix. Okay. So what exactly is the least number of operations you can use to multiply these two matrices? This type of pattern problems are called partition DP, and these are very frequently asked in interviews. This is of hard category. So I would recommend you all that once you complete the basic and the medium ones, you definitely do these questions. Okay. Okay, then let's wrap up our studies here. So do you guys have any questions to ask? Anything? So today is Friday, so tomorrow and the day after tomorrow will be weekends. So what do you guys do on weekends? Like if you are in your college, then I guess you must be utilizing those time for preparations, or because during weekdays you must be attending classes. I'm not sure about the other audiences, but I guess so. Since you're working as a professional, I'm sure that you get holidays during your weekends. And Pratik, what about you? Okay, so we have around 15 audiences right now. Okay, then. So let me just wrap up today's session with a small brief conclusion. So we studied about introduction to dynamic programming. We studied about Fibonacci numbers and how we can optimally find the nth Fibonacci number. We actually studied about tabulation and recursive memoization of 0 1 knapsack. And I also gave you a small introduction about matrix chain multiplication. Okay, so these are the things that we have studied here. And yeah, so let's see if I can actually take a new session, but I guess tomorrow someone else will be taking. Okay. Oh yeah, like too much work at your company, maybe that you need to take rest. Yeah. After a long gap, trying to get back into IT again, preparing for interviews right now. That is really, really great, Pratik. Okay, yeah. Hmm. So you were basically initially you were in IT background, or right now like you were from non-IT background and you are trying to get into IT. Okay, then whatever it is for all of you guys, I hope that you guys, I wish all the best to you all in every NDVs that you guys are taking, and I'm sure that you will whatever success you are trying to achieve, you will definitely get it for sure. Okay, right now also that I do have goals for my life and working towards it, and I hope that I do get back in it. Dabbed in business, so I'm not cut out for that though, so trying to jump back in. Okay, Pratik, that's really great to hear. Okay, then, a very good night. Enjoy your weekend, and yeah, bye bye. I hope I have shared my LinkedIn. In case if you would like to get connected with me, you can ping me up on LinkedIn. Okay, I do reply there. Okay, so yeah. Poonam is asking, is DP required a lot of practice? I mean, it is tough. Yes, actually, DP and graphs are the most important topics for interview. Okay, so let me just tell you, Poonam, is that if you are like upskilling yourself, and if someone is asking a DSA based interview, then topics like DP, graphs, linked list, binary tree, and these become very important. DP, graphs, linked list, binary tree, machine coding, and stacks and queues also become very important. Heaps also. So these are the very frequently asked topics for an interview point of view. So yeah, so solving these questions are actually very important if you are preparing, because DP is actually tough, and in fact you will not find you will find a lot of variations of DP, different types of DP. Like the last question that we did is called partition DP. The 0 1 knapsack is called DP on subsequences. Okay, so these particular type of DPs. Okay, so there are various patterns, and you have to solve problem based on those particular patterns. Okay. Okay, then I hope it's clear right now. So let's, yeah. Bye bye. Have a very good night and enjoy your weekend. Thank you very much.